let me try to come to my topic on the technology initiatives under the PMGSY. So once again, I welcome all the participants. There are more than 50 participants from the different states. I think 22 states were identified, noted down from the participants deputed by the NRIDA, and we have permitted some of our students also, scholars also, to be part of this training program so that they will also get benefited. And if you have some friends, your colleagues, working people who are interested in this topic, you can choose them. You can share the links with them. They can freely join us without any cost, free of cost. So we don't charge any of those people. So if you have any of your colleagues who are interested, who have not been deputed by your departments, still if they are interested in learning the subject, ask them to join this training program and share the link, whatever we have shared with you in the group. So this presentation is divided into 4 aspects. One is about the rural roads, need for the new technologies and issues involved in adopting the new technologies. And then we'll try to discuss about the mainstreaming of existing technologies. What are the technologies which are available, and out of which can be kept on the rails to adopting by the different departments across the country. And then the measures proposed to promote the use of new technology. What is the measures proposed by NRIDA? What they're saying, or how to promote the adoption of new technologies, because this exercise is being started about 10 years back. I think when I'm trying to look back 10 years back and then try to look at now, it's a sea change. There's the attitude, aptitude, and also the outlook of the field engineers in adopting the new technology. 10 years back, they're not inclined to adopt the technologies because of several reasons. Now there is a change. There is a positive change. There is a positive change, good for the departments, good for the field engineers, as well as good for the nation. Then the technology development and manuals. What is happening under the umbrella of the NRIDA? How the technologies are being developed? What are the various manuals are being drafted, etc. So those aspects will be going to discuss. Friends, there is a note on the technology under new technologies under the PMGSY, prepared by the NRIDA officials, and of course with the support of the technical experts. And this document is freely available in their website. It's about 15 or 16 page document. We are going to share with you. So my entire presentation is based on that note. Maybe here and there some concepts are being adopted to supplement the presentation. Now let's try to look at what are the rural roads. Briefly, let me tell you that the PMGSY scheme was launched in December 2000, and then by the time the government, the planning commission, then the government in place, they have realized the importance of the rural roads, because they found that for every 1 lakh rupees being invested in the 1 crore, I think 1 crore rupees being invested in the construction of the rural roads, they are trying to uplift about 150 or 160 families above the poverty line. That was the study by the planning commission. Then they realized that now if you want to develop the nation, you want to develop the rural areas or the rural habitations, where 70% of the population are still living in the rural areas, then it's worth investing, whether it is economically, financially, or socially, worth investing in construction or strengthening the rural infrastructure. Roads are the primary infrastructure, providing the accessibility, connectivity, and mobility to the people living in these rural areas. So that is the reason why they launched this scheme, PMGSY, Pradhan Mantri Gram Sadak Yojana, in December 2000, thanks to our late Prime Minister Sri Atal Bihari Vajpayee, and it is his brainchild. who has launched this one. We are enjoying the fruits even after 22 years of launching this particular program. So this PMGSY program is focused on providing a proper engineering structure, because till 2000, even though rural roads are supposed to be the engineering structure, but they never treated them as an engineering structure. So as and when the funds are there, small funds or fractional funds are available, they used to keep one layer of metal or one layer of gravel or something like that, and then sometimes they roll it, sometimes they may not roll it. That was the fate of the village roads. So they realized that the PMGS has emphasized that rural roads are also the civil engineering structure, which is supposed to be scientifically designed, and then that has to be constructed and maintained properly. So they also stress the quality and durability of these roads. Quality and durability of this. The quality of construction should be good. That is the much emphasized. Probably you might realize that by this time, the three-tier quality control and assurance mechanism, it was not there in the other schemes of whether the state or central governments. It's the first time under the PMGSY scheme, they introduced an excellent framework of introducing the quality framework, excellent quality framework. That is a three-tier quality framework. You're all of you familiar with that. At the same time, we would like to preserve the assets. Would like to preserve the assets, because the assets, rural roads are the assets which are being created, national assets. So they have to be preserved because they have been conceived and constructed by huge capital investment. So we should preserve them so that they withstand and serve the people during its entire lifetime for which they have been designed. So roughly, initially they thought that about 2 to 3,000 crores might be good enough. By 2007, they were going to wind up the project, providing at least all-weather one all-weather road connectivity to each and every village. But later people have realized that it is a mammoth task. So even today, in 2022, we have not completely provided 100% rural connectivity. Here and there, some roads are there in some of the states. So, but majorly, major villages are being covered, and all of them are being provided with a all-weather single road construction. The question is, each village might be having a two, three, four roads also connecting the surrounding habitations of the villages, or the surrounding market centers, or the nearest mandal headquarters, or taluk headquarters, etc. So, providing one good road is good enough, or we need to enhance or strengthen the other roads also. Maybe the PMGSY is focusing on at least providing one good road connectivity. That is ensuring it. So now we have realized that the 20 to around 20,000 crores are required per annum. That is the budget outlay. Now, day before yesterday, there is a series of national webinars being organized by the Ministry of Rural Development, and under the this NRIDA is also the main key player who is organized this event, where they have given the list out the statistics, saying that in the last 20 years they have spent almost about 3 lakh crores of rupees on road construction, uh, and then covering about 7 lakh, roughly around 7 lakh kilometers of road are being constructed in the last 20 years under this scheme, that's the PMGSY. So this is going strong, and the present government is also giving a lot of impetus for the construction of the rural roads, and they have allocated a very excellent budget portion for this particular scheme in the current financial year also. Now, having said that, let's try to understand the basic structure of the payment. All of you are the civil engineers, mostly I hope, and then you might have learned the cross section of the pavement or highway as a part of your highway engineering or transportation engineering one course during your BTech or Polytechnic also. So it's a typically layered structure. So from the weak layer to the strong layer, right? So the soil subgrade or the embankment is the weak layer, and then we are moving towards creating a more and more strong layer with a high bearing strength. So that's what we are trying to do it, gradually increasing it. If you are trying to look at bearing strength, you are measuring the CBR value, then the embankment might be 2, 3, or 4% CBR value. Then you are going to have some kind of a treated embankment, which is called as a subgrade, and then we have the metal layers, subbase and base courses, etc. And finally, a ceiling coat with a 20 PMC, etc. Now the question is why we want to have the new technologies. This is a conventional road structure, road cross section. So why are we not happy with this structure? Yes, we are happy. But many times, we are trying to construct the rural roads for the villages where the population is less than 1,000, less than 500, even 250. Now, in future, probably you may would like to construct the roads for the habitations with the population of 100 also, because they're also our citizens. We need to provide basic accessibility to these guys. So, when you're going to look at these roads, less than 1,000 population, then how many trucks are expected to move to those villages per day? Maybe 5, maybe 10. There might be the trucks are required, which are expected to take the goods or agriculture produces to the nearest market center, or bringing some goods or fertilizers, etc., from the market centers to the villages. How many trucks? 1,000 population. About, even if you take the average family size is 500, 5. So 1,000 by 5 is about 200 houses. 200 houses. So how much goods are the producers or the food items are required to be transported from elsewhere to these villages? Very few, very few. So in such cases, do you really require this conventional strong payment structure? True sense, they're not. You don't require. You don't require. That's what I said. In the initially, gravel roads are good enough, but somehow we have some kind of a negative tag with the gravel roads. But it's not so. Dr. Venkat Chaudhary is going to build upon on this aspect today, I think, in the last talk. So gravel roads are good enough. But the thing is, the social concept about the gravel roads, the ill effects, etc., etc. People want everything is a black tar. They don't want a dust nuisance, etc. Yes, we have a cost-effective solutions to remove the dust effect. The second problem is these conventional materials, you require a virgin aggregate, good aggregate particles, where they are available. We're already consuming lots of mountains, right? Hillocks, mountains are being consumed by us because of the construction of the buildings, the construction of roads, etc., etc. You know that the government of India has launched a scheme, want to provide a house for each and every citizen across the nation, villages, towns, etc. I think our Modi ji has said that by 2022, we want to have the house for each one, for each citizen. We have not yet realized, this. Not only that, there are several construction projects, infrastructure projects, so where the natural resources are required in a huge quantity. Similarly, the roads, high volume roads, yes, we require. But can we find out an alternative materials? Can we find out alternative materials replacing your aggregate so that the dependency on the good quality material will be reduced and the cost of construction? I vaguely remember in 2001 when we were scrutinizing the DPRs in the first phase, first year of the launch of this particular program, it's roughly around 5 lakhs per kilometer, less than that. But now it's almost 80 lakhs, 1 crore, or some states it's crossed more than 1 crore per kilometer. Cost of construction has become almost 20 times increase in the 20 years. 20 years. So where do you get the money? So ours is a developing country. It's not a cash rich or excess surplus budget. So we have a huge demand for the various sectors. So we have to affect the optimally utilize the resources available. So resources should be optimally utilized, and we should be able to reduce the cost of construction. The third point, there are several industrial byproducts, maybe fly ash, blast furnace slag, steel slag, marginal materials, natural available coil, or the jute. So can we use this material as a construction material, construction of the low volume roads? That is the beauty of the civil engineering. Who adopt, we don't reject any material as a construction material. We'll try to adopt the all local available material also. But only thing is the ingenuity is we have to test them, evaluate them, find out their suitability. Where can I use that material? In the subgrade or the subbase cores or on the WM layers or on the surface layers. So we have to test and evaluate each and every available, natural available material or the industrial byproducts and evaluate them whether they are suitable or the place or the layers in which they can be adopted or implemented so that the multi-purposes are being served. What are the purposes? One is cost of construction is coming down and saving the natural aggregate or natural resources for the future generations, and then effectively utilizing the industrial byproducts. Otherwise, disposal is a big problem. So these are all the multiple objectives with which this particular program, this scheme was launched and encouraging the usage of the new technologies. So that's what I said, that promote the cost effective and fast construction technologies and mitigate the problem of depleting natural resources. And then the mainstream, the technologies already developed through the R&D labs like CRRI, CSR labs or the IITs and NRIDs and so on. And then to undertake the further research and technology initiatives, taking into account the environment, terrain, accessibility, and other constraints. India is a beautiful country. From north to south, if you try to look at all our states and union territories, you have the different terrain conditions, you have different environmental conditions. So we have a different cultures, customs, and so we need to look at, and we have a different marginal materials, local available materials, which are specific to a particular geographical location. And ultimately, we have to protect the environment. You see that in the last 20, 30 years, how we have spoiled the environment. We have spoiled. I said that we means that I and you, all of us are the main reasons for the depletion of the environment because of the man-made activities, whether it's a construction or whether it's a traffic or whether it's a vehicle manufacturing or it's a thermal power, whatever it is, and we have spoiled the environment. We are not in a position to drink a tap water. We are not able to breathe properly. All our urban areas are being polluted. Two-thirds of the pollution in the urban areas are due to the traffic pollution. So there are several health hazards, whether it's a high blood pressure or the hypertensions or the diabetic or even the cancer. All these are all due to the pollution. So we need to look at our contributions to the air pollution should come down drastically. So these are all the, the, the reasons for us to adopt or to look towards the adoption of new technologies. Now, if you want to use the new technologies, so what are the issues? What are the issues in use of new technologies? Okay, maybe all these issues might be more pertinent about maybe 10 years back, but even then they are also relevant even today to certain degree, like a fear of failure of the new technology and accountability. There's an issue. Many of our engineering friends working in the field are they're worried whether the new technology is not a proven technology. It's not being applied, implemented, and they have not seen, we are not evaluated the performance. It's not well documented. There is an issue. So if it fails, then the people may say that, fellow engineers may say that his road has failed. And the seniors may also, the higher ups also may think that this fellow has not constructed the road properly. So this kind of a social stigma will be there. Then the apprehensions among the officers about the rate analysis. This is another issue. I think now slowly all the states are trying to address it. Whenever the engineers are coming out with when we are suggesting them to adopt a new technology, they say that the standard unit rates are not available in SSRs. So slowly we are trying to address this unit rate analysis in your SSR by different states. Similarly, inadequate technical know-how about the various technologies. The know-how is not well disseminated about 10 years back. Now we're well versed. I think the several series of workshops are being organized by the technology providers as well as by the NRIDA. I've seen that in the last 10 years, more number of workshops are being conducted to disseminate the knowledge. As a part of the 75 years of celebration of independent India, even last year, 2021, recently, NRIDA has taken a mammoth task of conducting a two-day workshop at different places, different states, deputing the engineers from the different states to across the other states, so that to demonstrate the success of the new technologies. In fact, as a part of that, I also went to Vijayawada, the state of Andhra Pradesh, and they have demonstrated the FDR technologies and also geotextiles which are being adopted in construction of two roads. So similarly, there I could see that there are about 30 to 35 field engineers came from the different states other than the AP. So this is how they are trying to build the confidence of the people, trying to disseminate the technologies. We have strict quality control. It's obvious because because the rural roads, especially PMGSY roads, are known for the good quality, and it has earned its name by its well-structured quality controlling mechanism. And obviously, whenever you are trying to adopt the new technology, you would like to know its performance. You want to effectively evaluate the performance of these new technologies. Obviously, in such cases, we would like to get the actual values. Actual values. So quality control measures will be there, but that should not be treated as a negative point by the engineer should not perceive it as a negative aspect. Then inadequate information about life cycle cost analysis. So those who have passed out the BTech like me about 30 years back, and there at that time, the adoption of any new project is based on a new technology is based on the initial cost of construction or initial investment. But subsequently, the thought process been changed. The approaches, attitude, the outlook has been changed from the decision makers and also engineering community. So because the road is being designed for 10 years, or 15 years, or 20 years, so during its lifetime, how much we are expected to invest, not only initial cost, because you have seen your cars or bikes or mobile phones, etc. Some of them might be initial cost is low, but the maintenance cost is more. But some of them, the initial cost might be more, later subsequently maintenance cost will be lesser. Now the concept is life cycle cost. Life cycle cost. So during its entire life, how much a owner, a user is expected to invest in the construction of cars, construction of the roads, as well as the maintenance, rehabilitation, etc., and then how much benefits we are going to accrue from that investment. So this kind of an analysis is to be carried out. This has to be carried out. But the engineers are not being well trained in these aspects. I think slowly people are getting this concept. They are trying to adopting this one. Then inadequate knowledge about the design requirements of different technologies. Technology providers, whether it's RBI 81 or Paradigm or etc., several people they say that they claim everything under sky. But the question is, they are not trying to give it transparently the design requirements or design details of their product. Maybe sometimes there might be tall claims, but what is necessary in order to build the confidence, in order to convince the field engineers that this can be adopted, they should be able to share their technologies. Their technologies might be doing wonderful results in the laboratory, but how they are going to perform in the field. Definitely, there will be a scaling parameter. One of my professor, Professor Ramamurthy, is going to address you tomorrow. He will say that about we have to take 70% of the performance of the laboratory may be reflected in the field. He is going to address you. So, what is that scaling factor? So for that, the technology providers should be able to share. In fact, as STAs and PTAs, many friends like me, my colleagues across the nation, they're trying to convince the technology providers to share these design parameters. We're also finding it difficult. Sometimes they're open and trying to share. Sometimes they will try to shield the information. Okay, things are improving, right? The reluctance of the states in coming forward with the new technologies and reduction in the cost. This is another thing. The cost of road, I could see a rat race among our fellow engineers. If I say that as in charge of some X road, my cost of construction is about 50 lakhs per kilometer. The other person, other colleague in the next division, you will also try to see that the estimation, cost estimation will be roughly around 50 lakhs per kilometer. But that road may require only 30 lakhs. That road might be, soils upgrade might be good. You don't require a thickness, reduced thickness is good enough. And then his road might not be having a number of cross drainage structures. So in my road, what I propose, there might be 3 or 4 cross drainage structures per kilometer. In his road, there might be 1 cross drainage structure. So the cost of the construction of the road will never be uniform across the globe, across the states, or within the same state also, within the same state also. So people should realize that. People should realize that what the NRIDA or what the state government says is an average cost. They may say that okay, average cost of construction should be around 60 lakhs per kilometer, 70 lakhs per kilometer. But half of the road, what is average? Average is a middle point. That means 50% of the roads are expected to have a cost less than 50 lakhs, which is an average cost, or 50% of the road should be more than the 50 lakhs. But I sincerely says that, and all our field engineers should move away from this concept of bringing every road to the average cost or trying to boost up the cost of construction. I don't say all the engineers are doing it, but there is a tendency among a few engineers to enhance the cost of construction. So such people definitely will be reluctant to use the new technology. And some cases, in some people are trying to exploit the new technologies. In the name of new technologies, they will try to enhance the cost of construction by the providers. Then the non-availability of standards and specifications for the construction, but this is not true. And many cases, like there are proven technologies, lime stabilization, and then the cement stabilization, etc., who have a well-established course of practice. We will see in the subsequent one. But for some of the technologies, yes, the standards are not available, specifications are not available. But that is where our fraternity are trying to improve develop the specifications. And the lack of awareness by contractors. This is another issue what we are facing in our country. They are not. Some of them are not professionals. And you could see a professional contractors on the high volume roads, but these are all the low volume roads. Maybe sometimes the contracting value might be, a tendering value might be around 40 lakhs, 50 lakhs, 60 lakhs, etc., etc. You are unable to attract a professional contractors. They are that I think the less we speak, the better the type of contractors we are getting for the construction of the low volume roads. Many times they don't know ABC of construction also. So we need to attract, we need to upgrade the knowledge of these people also. Non-availability of indigenous equipment. Now slowly you could see that agriculture tractor is being effectively utilized in the construction of low volume roads, polarizing the soil or for the stabilization or mixing, etc., etc. They are using it. But the equipment where the problem, especially compaction, etc., for when you are widening the roads from 3.75 meters to 5.5 meters intermediate lane. So 1 meter on either side, developing a layer from the bottom, subgrade level to the surface level, and that's where the people are feeling or facing the difficulties in the form of the compaction equipment, rollers, etc. Of course, now I saw some of the smaller rollers in the market. Then the lack of information on performance of the roads. This is another issue. We need to document. We need to document across all. We have several institutions across the country, and several qualified processors are available in transportation engineering. Probably have to utilize their services in recording the performance of these roads constructed with the new technologies. That's where we also play a critical role. You also play a critical role. You are the actual people who are dealing with the roads, who are touch with the roads, so probably you can get the data, quality data, and if you can get a good support, probably you can, as a team, who can bring out the performance reports of all the different technologies, so that what they can, where they can apply, how they can perform, and what circumstances you can add the new technology, etc. We can come out with a certain manual. And the proactive role of states and as well as STAs is not seen. Of course, now there is a change. STAs are interested, they are proactive. For example, at NIT Warangal, we have 3 specialists exclusively on the payment performance. Dr. Venkay Chaudhary, Dr. Shankar, Dr. Vishnu. These 3 people are going to take more topics, and you will see them more and more times. And they are well versed. We have an excellent laboratory in case of the payment material testing or evaluation of the mixes, etc., etc. So we are interested. You want to go anywhere, as long as you give support, yes, we are ready to take up the challenges and carry out the performance studies. When compelled efforts to make higher provisions and prove that the technology is not cost effective, even the lead is higher. This is also some cases, very few cases, I don't say all the cases, very few cases, 1 or 2 cases, you could say this kind of a trend also. Then identifying some most ignorant junior most officer and deputing to the NRIDA for discussion. And of course, this is the point raised by the NRIDA, and especially the new technologies, the proper responsible officers are not being deputed. That's what they felt. Now, having said like that, with that background, so what are the technologies on which we are supposed to give a focus? So the immediate focus is available marginal materials. There are several marginal materials across the nation, different states. They are not one and the same. The marginal materials available here and there need not be the same. AP might be some kind of material, Telangana there may be something, Tamil Nadu, UP, different states have different types of marginal materials. Can we use them? Because otherwise it is a waste material. Can you use them? Maybe can you use it as a subgrade, or by treating these marginal materials, can I improve the bearing strength and hence use it as a sub-base course? That's what we ought to look into. That's the reason why I said that civil engineers are the more nature-friendly engineering, because we want to adopt all types of materials, we want to test it suitable. You cannot neglect, you cannot reject the materials. We have to find out where it can be used. Can I use it as a subgrade, or can I use it as a sub-base course, or can I use it as a base course? By proper treatment, of course. The treatment might be necessary. Little intervention, probably you can enhance their qualities. So the first priority is we have to utilize the marginal material so that you can save the quantity of marginal material more. Then obviously that equal quantity of aggregate you can remove, or equal quantity of a sub-base, other good soils to be borrowed, you can avoid it. Then the industrial waste. You have thermal power plants, steel plants. So there are a lot of byproducts in the name of fly ash, etc., blast furnace slag, etc. Can I use them as a construction material? So fly ash can be used in the embankments, right? And so that costly soil need not be borrowed from elsewhere. Or it can be used with the cement, so that you need not lose the strength characteristics, your durability will be increasing, etc. And similar new materials accredited by the IRC. You all know that the Indian Roads Congress is the premier organization in the country, under the aegis of Minister of Road Transport is working, and it has a mechanism to look at the quickly evaluating the performance of the new materials entering the market. Then they will accredit. Accredit means that they will try to see that whether the material is performing well and its potential usage is there. Then such materials are identified by the IRC with the help of the national laboratories. They say that yes, this material can be adopted in the field, and they'll give for the accreditation for 1 year, 2 years, 3 years, depending upon the requirement. And based on that, they have to adopt and see the performance, the field performance. If the field performance is good, acceptable by the field engineers, then such materials can be mainstreamed, can bring into the construction field. Then the environmental friendly new technologies, like a cold mix, warm mix technologies are coming up, because the hot mix technology, you need to heat the material, aggregate, both aggregate and bitumen to 160, 170 or 180 degrees centigrade. There's a huge energy is required. Huge energy is required. Can I adopt the cold mix? Can I mix the aggregate and bitumen at the room temperature or environmental temperature, local temperature? So that we are saving a lot of energy, pollution is also being minimized. The warm mix is a little bit in between the cold mix and the hot mix technology. So where the energy saving is the one, pollution will be reduced. Jute and coir geotextiles is another one. Jute is abundantly available. Coir is abundantly available in Kerala and coastal areas like Andhra Pradesh also. Then this, can I use it? Otherwise, you are throwing out, right? Can you use that on the construction, like geotextiles? Can you make it and use it? And where the subgrade level, improving the quality or improving, overcoming some of the shortcomings of the soil supply. Waste plastic. Plastic is the one. Waste plastic is the one which is flooding all the towns, habitations, right in and around. Whenever you approach a major city, town or village, also you see the entrances are very ugly, and waste plastic is abundantly available on the sides of the road, clogging the drains. Right, is also, it's one of the reasons for the animals also being killed, because animals unknowingly they are also consuming this waste plastic bags, etc., etc. Can we use this? Can we use this? Can we use it as a modifying the properties of the bitumen such that the durability of the bituminous concrete layers or bituminous layers might be improved? So these are all our concerns. These are all the ways where you can focus and adopt these technologies. So these alternative materials can be broadly categorized. It's like academic exercise, like a manufactured materials like a cement and fibers, etc., and the natural materials like a coir, jute, etc. Waste materials like a crumb rubber, waste plastic, which can be used to modify the properties of the bitumen, and hence the durability of the bituminous mixes will be improved. And then the industrial products, byproducts, like a fly ash and slag, fly ash and slag. So, etc. can be utilized. Now, let's try to look at some of the technologies which can be mainstream as suggested by the NRIDA. It's a document. So, there are several proven technologies beyond doubt, whose performance has been evaluated, specifications are drafted, and codes of practices are being developed. So we call them as the proven technologies with Indian Roads Congress codes of practices or specifications. Like a soil stabilization, the lime stabilization, they have a good code of practice. Cement stabilization, bitumen stabilization, and mechanical stabilization. These stabilizations can be adopted in field without any hesitation, without any doubt, because these technologies are already proven. How to use it, where to use it, etc., step-by-step procedures to use or stabilize the soil or stabilize the surface layers, whether using lime or cement, etc. All these things are documented, well documented, as through the guidelines, the codes of practices, or specification books like IRC, etc., etc. So these technologies, without any hesitation, all our engineering friends, you can use it. There is nothing like a failure of the road. There is nothing like a failure of a particular layer where we are stabilizing it, because these are proven beyond doubt both in the field as well as in the laboratory. They were tested in laboratory, they were tested in the field, they have proven technologies. And these technologies can be adopted by each and every one of you. Okay? But only thing is you have to go through the code books, and we are having a topics, individual topics on each and every technologies in the subsequent classes. Okay? Tomorrow morning, 9 to 10:30, we are going to have a stabilization, a topic on exclusive topic on stabilization. Then other proven technologies are the use of fly ash and pond ash. Fly ash is a waste byproduct from the thermal power plants. So they can be used in the road embankments as a filler. They can be used in the cement concrete. So they have the course of practices. IRC SP 58 and similar IRC 112 2020 is recently updated. And then the roller compact concrete pavements. There is again a code of practice. Interlocking concrete block pavements. We have another code of practice. Cold mix technologies. Waste plastic utilization. NRIDA has given a guidelines. This document can be downloaded freely. Even the IRC codes of practice. All IRC codes of practice are now available free of cost. I could see in 2000, 2005, 2010, 15, I could see a lot of people claiming, saying that the codes of practice are not available. Codes of practice are also not available. And in fact, that responsibility has taken by the NRIDA. We have to thank them. They have procured codes of practices, relevant codes of practices applicable for the volume roads, even the IRC SP 20 also. And they have supplied to the each and every state. I could see these books are available in the CE's office. When I visited some of the CE's offices, I could see these books are available. These books are taken by a few engineers, but the poor engineer who is at the PAU level, program implementation, district level, these fellows, they don't have these course of practices. Somehow they are trying to get borrowed, xeroxing it, etc., etc. And also the second problem is that engineers, if they want to procure these codes of practices on their own, the cost is exorbitant. Your IRC code of practice might be 15 pages, 20 pages, the cost is about 200, 300, 400. So engineers' salaries are not that much like a software engineer's job, right? So they can't, even if they want to have it, they can't. So I used to say that number of platforms saying that why codes of practices should be priced at highest level. The engineers of the nation, they should freely access these codes of practices. These codes of practices, specification books are not available freely to the engineers. How do you expect this engineering community to construct the roads, adopting these codes of practices, following these specifications? Then how do you expect a miracles in getting a good quality roads? Somehow there is a change in the thinking process. Now the IRC codes of practice are freely available. You can download. And you can use it. Now you cannot say that no engineer in India should say that I didn't have these codes of practices and hence I could not adopt it properly. No, you don't have that luxury of giving us such statements. The codes of practice are available. Similarly, gravel roads, you have the code of practice. How to construct, how to design and construct these gravel roads in this country. 1 minute.
Sara.
Yeah. Now there are other technologies like local available marginal materials, etc. We have the IRC, blast furnace slag, steel slag, etc. We have the course of specifications. And then the geotextiles, we have the HRB special publication. And then the risers is coming up. This accredited, these are also accredited materials. Then we have the bioengineering measures like a jute, bamboo matting, etc. Again, there is a specification book, Highway Research Board of the IRC. The state of the art document is available. Now let's try to have a little concepts. I am not going to have the in-depth discussion about these various technologies. Just I will try to introduce a basic concepts, and then we have the detailed discussions in the subsequent classes. Like stabilization. What we are trying to look at is we want to make the unstable soil as a stable. What is stability? What is instability? Unstable soil is one which is unable to take load. What are the loads? The axial loads, traffic load. Vehicles are moving on the road, then they have huge load, axial loads, even standard axial loads of 8 tons. And now you could see the axial loads of 10, 15, 20 tons, dual axles, right? So you have the huge axial loads applied on the road repeatedly at different time intervals. During its lifetime, you could see hundreds and thousands of vehicles moving on that. So on such load applications, if it is unstable, unable to take load, fails in the shear, and shows excessive volume change, then you call it a unstable soil. If you want to make it as a stable, or you want to improve the basically a bearing strength of the soil subgrade. Basic strength of the soil subgrade. Basic bearing strength of the subbase course also. So there are different ways, both physical and chemical alteration of soil properties. Physical alternatives is nothing but your mechanical stabilization. The chemical alteration of soil properties is nothing but your lime or cement stabilization, etc., etc. So these technologies are available to treat the different subgrade materials. Where the poor, about 30% of our soil in India is a black cotton soil. It might be good for the agriculture purpose, but it's a poor construction material. So to increase the strength, thereby increasing the stability of the slopes, and there are embankments, yes, we need to have the stability of slope. Improving the load carrying capacity of the subgrade. The subgrade now the code the PMGSY guidance also says that you should have a minimum 5% now, right? When the scheme was launched, there is no such restriction. The IRC says that IRC 37, the CBR value of the soil subgrade is less than 2%. You should have some cap layer, a drainage layer, around 150. And then over that we have to. But now initially the PMGSY has accepted that. Subsequently, they said that the minimum CBR of the soil subgrade should be 3%. Now they made it as 5%. See that in 20 years, we are trying to improve the standards. Because we have realized, we have experienced that if the soil subgrade is poor, then the cost of construction of the road is going up. Performance of the road is not up to the mark. So now we have identified the problem. So subgrade CBR value has been improved to minimum of 5%. Good soil, yes, you can have a subgrade with 5%. The poor soil is less than 5%. Then improve it. Treat that using the appropriate stabilization techniques and make it 5%. Earlier thinking is replacing the poor soil with the good soil. But where do you borrow? How long you borrow? How much quantity of good soil is available? Is it difficult? So whatever the local available soil, you have to improve it. Using the adopting appropriate stabilization technique, making it 5%, at least 5%. There are advantages. One is you are trying to reduce the failures, you are trying to reduce the thickness of the pavement, and hence the cost of construction will come down. durability will be gone. This is the idea. So stabilization has to be adopted. Even some of our friends are reluctant because of the laborious process involved in the stabilization of soil subgrade. Many of our engineering friends are reluctant to use the soil stabilization even today. Somehow I could see a few cases, even though soil subgrade is 2%, 3%, they say that no, design CBR of soil subgrade is 5%. Try and get some reports. You can hide it in the papers, but you cannot hide the actual performance of the payments in the field. So we have to adopt the stabilization. So the NRIDA is also increasing, is adopting as suggestion that we have to go for. To reduce the permeability of the soil, to reduce the compressibility and frost susceptibility. One of our friends in the initial stages, they said that from Jammu and Kashmir. So he said that frost susceptibility is there, because of which their road has been filled. So we need to address it. That may not be a problem. Frost susceptibility is not a problem in South India, Tamil Nadu, Kerala, or Andhra Pradesh, Telangana. But it's a problem in the states closer to the Himalayas where the frost formation is natural. To control the shrinking behavior, shrinking properties of swell and shrinking properties. This is also one of the reasons for the failure of the payments if they are constructed on the block control soils. So we need to adopt the soil stabilization techniques wherever, whenever they are required. So in the process of stabilization, they are bonding the soil particles together, so and hence the strength is increased. Fill voids so that reduce the permeability, improves the compaction by lubrication and particle reorientation, etc. So the focus is the benefits are the reduction in the plasticity, reduction of pavement thickness, and aids the compaction. So what are the soils where you can apply the slime stabilization? Most effective in soils possessing the cohesion like clay gravel and gray gravel binder mixes. So you need to identify that also. You should know where you can apply lime stabilization, when you can apply cement stabilization, when you can adopt cement or lime for the stabilization, or when you can go for a mechanical stabilization, when you can go for a bitumen stabilization. This we need to understand. That is the reason why I said that civil engineer is a nature-friendly engineer. He has that ability to identify the suitability. See, you should, all of us should have that ability to identify the suitability of the material, where they can apply, or what is the appropriate location. Similarly, you have the course of practice now. It's not a rocket science, right? Now, what are the types of soils where you can apply lime for the stabilization? That's what they said. Cohesion, pursuing the cohesion like clay gravel or gravel pines. Minimum clay content is also said that. The minimum said is 20%. So soil passing 75 microns should be less than 35%. Plasticity should be more than 10%. So in sandy soils and silty and loamy soils of low plasticity, lime alone is not enough. It is also said that in these cases, lime alone matters. So you need something else, maybe cement, you have to add. So we'll have the more discussions on these points tomorrow morning, right? So for the cement, for cement stabilization, gravel, sand, silts, clays, cinders, and etc. are useful. So sand and gravel soils with 10 to 35% of the fines are good for the cement stabilization. Similarly, organic soils are not suitable for cement stabilization. So you need to identify what is the type of soil you want to carry out, particle size analysis, all properties, and then we have to judge that what type of stabilization is good. Rice as ash is where are the rice is the predominant crop. So this is a waste product, right? It's a waste product. So it has some kind of a silica with high specific surface, so and hence it can be used as an additive. Similarly, baggage ash, wherever the sugar cane is been crops is predominant. So this nothing but the wastage of sugar manufacture. So the solid waste material known as a bagasse. So there is also pozzolanic material which can be used in the for stabilization, etc. So this is where, as I said that in the initial slides, the agriculture tractor, they are plenty available, abundantly available in almost all the villages. Now agriculture tractor is a basic tool. This can be used in the stabilization of soil with a little accessories. Now there are locally available materials. What is the need? We said that the availability of quality aggregates is becoming a serious bottleneck because these aggregates are depleting, quantity is depleting. Because we have the several road development programs. Even the recent budget also, they said that they want to construct 25,000 kilometers of national highways in the next 1 year. There is a huge project, Bharatmala, right? They have the connectivity, road infrastructure. Infrastructure, they have given few lakhs of crores of rupees. Focus is on infrastructure development. Recent budget. Strengthening the ports, strengthening the railway lines, strengthening the road network, so on. So you require a huge quantity of natural materials, aggregate. The way in which you are progressing, the way in which you are using these natural resources, no time, maybe 5, 10 years down the line, this aggregate particles may disappear, may not be available. And what will happen to our future generations? So we have roughly around 58 to 60 lakh kilometers of road, but all the national highways, maybe 2-3 lakhs kilometers. State highways, another 4-5 lakh kilometers, right? So major district roads, 5-6. So roughly all of them put together is about 10 to 12 lakh kilometers. The remaining 45 to 46 lakh kilometers of road length belongs to the Panchayat Raj. They are the village roads, they are the ODRs, where the traffic volumes are much low, much low. That's where you can experiment. You can experiment the local available materials. You can save, you can preserve the costly quality aggregates. So, but these locally available materials may not be useful may not be suitable for the direct usage. So we have to treat them. We have to improve their properties. So they have a course of practice. There are several marginal materials like soft aggregates and so on. So they can be used by suitably modifying them with addition of lime or cement or additive other than the cement lime, even through the mechanical stabilization. So what is that you are modifying? In order to improve the strength and quality standards, cost reduction. Because of which usage of these materials, they are using the cost reduction, that means they are saving the money, and we are also protecting the environment, etc. Now there is a standard terminology, this marginal materials we are using it. In some countries they call it as a non-standard or non-traditional materials, or we are calling it in India as a local or marginal materials. So they have given some definition. The World Road Association, PARC, located in Paris, they said that any material not whole in accordance with the specification in use in a country or region for normal road materials, which can be used successfully either in special conditions made possible because of the climatic characteristics or recent progress in road techniques or after having been subjected to particular treatment, you can use them. So there are several materials like muram, laterite, shale, brickbats, light, etc. So these local materials have been scientifically categorized or grouped into 5. First one group is hard racks, weak racks, natural gravels, very crushed, manufactured materials, and so on. So there are several materials, like a construction waste is the one which comes under the industrial waste or waste materials or industrial byproducts. Construction waste, marble, dust and slurry, plastic waste, quarry waste materials, blast furnace slag, steel slag, zinc slag, rice ash, paper mill sludge. These are all the materials which are abundantly available now, large quantities. You have to dump them. Probably you require a huge space for the dumping also. Some of these materials may not be environmental friendly, they are not degradable. They not mix and dissolve into soil. For years together, dissolve them, regenerate. So better to use it as a construction material. So construction demolition waste, it's available in large quantities. Most of the cities, old buildings are being demolished and new buildings are being constructed. Large materials are available. This can be used as replacement for the aggregate particles, the slight treatment, proper treatment. So where the gradation can be analyzed, see that whether the mixing with the other natural material or some other material, you can make it as a suitable or achieve the suitable gradation for the construction. Another byproduct is the fly ash. I said that the government of India has also given a stipulations saying that in and around 100 kilometers radius of the thermal power stations, you have to use this material in the infrastructure products, including the roads. You can use it as a blended material for the cement. Now the cement itself is coming up, blended cement. And then IRC is also given a guideline saying that the minimum cover 60 meters, 60 centimeters on the fly ash. You can use it in the embankments, embankment filling for the high volume roads or low volume roads. But in case of the low volume roads, they said that 30 centimeters cover might be good enough if you are using the fly ash as a embankment filling. So it's also used for the stabilization of clay soils. There are several power plants, several thermal power plants, geographically distributed across the nation. So huge quantities of material is available, which can be used the bottom ash or pond ash as a embankment filler. Okay, and there are several integrated steel plants where you have the steel slag is available, million tons per annum. All this material can be used as a subgrade, the base course or sub-base courses depending upon their properties. Several leading institutions like IITs, CSI labs, CRRI, etc., NITs, they also tested. In NIT WARANGAL also tested the Visakhapatnam steel plant, blast slag. They found that they are suitable, were recommended for construction of their internal roads. So several of the internal roads of the Visakhapatnam steel plant are being constructed using their slag, steel slag. It's used in the sub-base and also the base courses, depending upon the suitability. You have to test all these materials and see that whether they are satisfying the required specifications or not. So there are several tests. Of course, blast furnace slag was tested. They found that they are all well within the limits of their applicability, usage, either in the sub-base course or the base courses, etc. Cold mix technology is another new emerging technology. As I said that using the emulsions can always mix the bitumen with the aggregate particles at the normal environmental temperatures. So this will avoid completely the heating of the aggregate, heating of the bituminous materials. The second problem is the rural roads are in the remote areas. The length may be half kilometer to 5 kilometers, maybe 6-7 kilometers. The ODIs, other district roads, may be about 7-8 kilometers, 10 kilometers, 15 kilometers. But the most of the roads, maybe 80% of the roads, less than 5 kilometers, maybe 1 or 2 kilometers also. So if they are in the remote areas, it's difficult to transport the hot mix, or the plants might not be available closer to the these rural areas. That's where I think there's another reason for you to adopt the cold mix technologies in the remote areas, especially the forest areas, etc. So the cold mix process is required because as you said that workability uh, plants might not be available, but they can be mixed at the site using the site mixer. Or if you have a plant nearby plant, then you can call it a plant mix. Road mix is uh, maybe for a low volume roads, low volume works. It might be like a concrete mixer for small and medium works can be used. Whereas for where the plant mix is available for high volume work, sufficient infrastructure is available, then you can go for it. Of course, have the few projects bundled together as a package, and if you require more and if the plant is available, yes, you can go for it. So these are different steps involved in the cold mix technologies, uh, adopting the aggregate and it's like a mixer is used on the roadside and trying to, this is a plant mix one, this slide indicates. So it's showing the mix with the slow setting characteristics, which can be spread and then you can utilize it. You see that people are using the slippers alone if you're able to move on that. Of course, it's not advisable as a safety point of view, etc. Then this cold mix technology has been evaluated in the laboratories and also in the field to a certain extent. Several institutions, IIT Guwahati has done a good work, the CRRI has done, even the IIT Kharagpur, and then the NIT Warangal, some of the institutions, leading institutions have done this technology and performance is being evaluated. They found that the performance is on par with the hot mix technologies. Then the geotextiles has to be promoted. As I said that jute geotextiles, coir and plastic geotextiles. I think there are extensive use of the geotextiles, especially in the Karnataka, in Tamil Nadu, Karnataka, Kerala. They're using a coir geotextiles extensively. West Bengal jute geotextiles. They're extensively using it for the improving the or enhancing the bearing strength of the soil subgrade. And these are all the plastic cells, okay, laid on the subbase course. So, cell, uh, cell-filled concrete pavements are extensively used. I think this is the technology promoted by the IIT Kharagpur, Professor Pandesab and his team. And they are being used extensively. They have transferred the technology. They are willing to transfer the technology to the various PAUs, whoever is willing to adopt it. So this is the roller compact concrete finishing, right? Gravel roads is the one, as I was saying, that majority of the roads, more than 50% of the low volume roads, they can be constructed with the gravel. They can be gravel roads. Try to look at the USA or developed countries, and they say low volume roads means that there are only gravel roads. Might have seen the cowboy movies where the horse is running and then the red colored dust is flying in the air. So they're all gravel roads. And that is how they perceived it. But Indian public is not in a position to accept these gravel roads because of the dust nuisance during the summer and the mud slurry in the rainy season. So can we adopt? Can we think of? Can we think of providing a ceiling options for these gravel roads such that the gravel roads can be used effectively? So if you can provide that confidence, yes, probably you can save a lot of money, lot of material, aggregate particles in the construction of the roads. In fact, NIT Warangal has a good experience, excellent experience. Dr. Venkay Chaudhary, Shankar, etc. They have involved, constructed two roads nearer to Warangal city, and they have provided a surface dressing on one road, open graded premix surface is another road, and they evaluated the performance for 3 years. They found that the roads are doing well, they're performing well. So it is a good option. It's a proven technology. Sealed gravel roads is an option and to be adopted, and it should be seriously think about in adopting the PMGSY scheme. So the government of India, NRIDA, is trying to map all these materials on the JS platform. All these materials on the JS platform. A couple of days back, the government of India, as the Minister of Rural Development, has launched the platform, GIS platform, GeoSadak. GeoSadak is the website launched by them, and where they're trying to bring all the low volume roads. They said that they have connected 10 lakh habitations. 10 lakh habitations. See, as for the government of India, there are about 6 lakh revenue villages. Revenue villages, a group of habitations, clusters of the habitations are being considered as revenue. So they have identified 10 lakh habitations. They have identified about, if I remember correctly, about 25 lakh kilometers of the low volume roads still going on. They want to identify, geomap, georeference all the roads. They want to identify, see the progress of the construction. They want to see the performance of each and every road. They want to mark everything. Everything they are trying to bring up on the open source JS platform, and they want to make it useful, accessible for the public also. So we can also map the materials available, locally materials available across the nation, so that the location, quantity of the material available, etc., we can look into that. Friends, it's almost 10:30. I will stop here. There are some measures proposed by the NRIDA about 15% of the load. The length of the annual proposal should be using the new technologies. And also they have given certain guidelines how to use, where to use, what are the measures to be adopted, etc. For the adoption of new technologies. Proven technology is one category, about 10%. 5% is the accreditation materials. Use it, and they have send a mechanism like a technology provider, PAUs, and that is our SRRDA is the PAU, NRIDA, and also the STAs. They should come and OU performance how to be evaluated. They have given a procedure for the evaluation of these technologies, well documented procedure, and even the yesterday's meeting, for the budget on several themes, the government of India is launching a national webinars. Yesterday on the rural roads also national seminar was conducted, where they said that they are giving an emphasis on the new technologies, and also they want to encourage the institutions to take up the research in the area of the low volume roads to enhance the durability of the roads, improve the performance of these roads, and reduce the cost of construction, adoption of new technologies. These are all some of the multiple objectives with which they are trying to encourage the technologies. Because these are all the procedures. Mechanism, the STAs, PTAs, PAUs, technology providers, they should all come together to work in developing the new technologies. Of course, there are several manuals or handouts are being prepared by the several institutions or technical persons or experts involved, and for the dissemination, several workshops are being organized at the state level, national level, and regional level by the NRIDA, and also they identified the training requirements. That's the reason why you are here now. We are also here connected to conducting the training programs. This is one of the objectives. That's what it is. This training program is only exclusively for the enhancing or also disseminating the new technologies. Of course, we have cited some kind of a boarding system for all the people involved, all the field engineers, etc. Maybe an appreciation letter at the national level, and probably that will go a long way for the field engineers and motivate them to adopt these technologies in the road construction. Okay, so So these are all some of the technologies which are being already adopted across the country.